Hey, hi everyone. Today we'll be discussing the topic of serialization because serialization forms the basis of all the data movement that you see on a computer. Example, I save some data on the hard disk in an RDBMS solution. That's serialization. I want to read data back from a database. That's deserialization. I want to open up a browser and look at some data, or just want to browse some web pages. So that's exactly serialization and deserialization in the sense, first of all, you are making a request to the server, you are getting back a response, and the response is nothing but a byte array from the server. The byte array somehow gets converted to a web page on your browser, and that's deserialization. So it forms the basis of any data processing, any data conversion that you're doing, and the data movement across the different components of a computer, and it plays the most central concept in computers and one of the most neglected concepts also. So let's go for a quick deep dive. My name is Kunal Gautam. I work as a principal architect for one of the man companies with over 16 years of experience. I had my own startup known as Windex, worked across 20 plus countries for 50 customers, and have spoken at multiple big data and AI conferences around the globe. So let's begin with the basic that computers are binary machine. So what it means is it can only understand 0 or 1. So it means that either you manipulate numbers or strings or character. End of the day, everything has to be represented as a number. So let's quickly go into the basic understanding of the number system to begin with. So what's a number system? A number system simply means that hey, somehow I have to figure out the symbols and then in the human brain the relative weight across them. Example, if you take a decimal or a base 10 number system. So base 10 number system will simply mean that there is gonna be 10 different symbols out there. So starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and post 9 you have exhausted all the symbol, so 1 0 will appear. And only in the human brain 1 is more than 0, 2 is more than 1, 3 is more than 2. In the number system, like if you write it down on the paper itself doesn't understand that 1 is more than 0, right? The interpretation lies in the human brain. Similarly, in the binary number system, you have only two symbols, 0 and 1. So what happens? 0, 1, you exhaust all the symbols, so 1, 0 comes up. Then 1, 1, you exhaust all the symbols, that's how 1, 0, 0 comes up. And then you are able to map. Decimal 0 is mapped to 0, 0, 0 in binary. 1 in decimal is mapped to 0, 0, 1 in the binary number system. Can we take another example? Let's say an octal number system. So octal number system, how many symbols it will have? 8 symbols. It means that it will start with 0, go all the way up till 7. Post 7, you have exhausted all the symbols, so 1, 0 will appear. Just look at the relation. In the decimal number system, it goes all the way up to 9, and then 1, 0 comes up because you have exhausted all the 10 symbols that you had starting from 0 to 9. In binary, you had two numbers, or let's say two symbols, you exhaust them, and that's how 1, 0 comes up. So that's a quick one for the number system. Just keep in mind, computers, because they are built on capacitors and transistors, they can only save 0 and 1. That's the reason it's based out of the binary number system. So it means that either it's a digit, character, string, it is all mapped to a number to begin with. So what do I mean by that? So let's quickly look at what is the difference between an integer 9 and character 9. So for character, computers have defined an ASCII code. What it means is every symbol or every character is mapped to a integral number to begin with. So 9 is not mapped to 1001 as a string. Rather, if you look at this chart, this is the ASCII chart. Yeah, and ASCII is like a standard. They have simply said they simply came up and they defined that a capital A will be represented by 65 number internally because computers cannot understand character, right? So if we just try to spot 9 here, which is this place, so character 9 internally is represented as 57. While integral 9 what will happen is you do a conversion of 9 into 1001. And how will you do that? You start dividing by 2. So you are getting a remainder and then the quotient. So 2, 4 is the quotient, remainder is 1. You keep doing that until unless you come back, you come down to either 0 or 1, because that's the only remainder possible if you divide something by 2. There is only two possibilities: either the remainder is 0 or the remainder is 1. And then when you try to write it, you write it from the left all the way up to the top. So 9 is represented as 1001 in the decimal number system. Just keep in mind, this is a logical mapping. This is how you derive 9 in the decimal 10 number system is being converted into a, a, a binary number system. From the binary number system, is it possible to get back the decimal? Answer is yes. How will you do that? So if 1001 is there, what you do is 1 into 2 to the power 0 plus 0 into 2 to the power 1 plus 0 into 2 to the power 2 plus 1 into 2 to the power 3. So this becomes 8. This all becomes 0. This is 1. And that's how you are able to do the conversion back to 9. Great. If this basic concept is clear, let's quickly go for a deep dive into what's happening inside your computer. So a quick one, when you are writing a Python code, be it your Jupyter notebook, be it your PyCharm, and you save it, just keep in mind that Python program is saved as a file on your hard disk. And just keep in mind, hard disk doesn't understand it's a Python program or a Java program or a C program. Hard disk only sees byte arrays internally. So whatever you have written, it's just saved as the byte array. The moment you double click, especially for my folks who are using Windows, you double click on something, it spins up. What do I mean by that is the program or the code is mapped back to the RAM, and the moment it goes to the RAM, CPU is allocated to it. And that's how the moment the CPU or let's say the logical power is given to it, you are able to interact with that solution. And that is what we call as a process. So now just taking this concept, abstracting this concept, in the Python code, you have defined a Java class, you have defined a class, and then inside the class, you have defined integrals and string. So what happens is those integral and string will be allocating some space in the RAM. What is that? Let's quickly have a look here. So this is a class, and I have just tried to generalize it. You can map this to a Python code or a Java code. So it has two instance variables, roll number and name. In the first place, if you see, it's both of them are of type string. So what will happen is one will be mapped to based on this logic, right? So one will be mapped to 49, blah, 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 and they all are of 1 byte each. 1 byte means 8 bits. So it simply means that if 1, 2, 3, 4, 5, 6, 7 was mapped as a string, in that case, it is gonna allocate 7 bytes in the RAM. And Maverick, because the length of the string is 7, again 7 bytes will be mapped here. The moment I convert this roll number into an integer, and again, I'm assuming we are writing a Java code because in Java, integer is mapped to 4 bytes. So 1, 2, 3, 4, 5, 6, 7 will be only consuming 4 bytes or getting 4 bytes allocated in the RAM, while Maverick will be allocated 7 bytes. So what you can see here is, first of all, based on the data type, the mapping on the RAM is different. And that's super crucial and important. So whenever you're learning a programming language, you have to understand what is the data type, how much size it allocates on the RAM. Because at the end of the day, when you're writing a code, all you are trying to do is you are trying to optimize the usage of RAM, CPU, disk, and memory. So lesser footprint I will have on the RAM, faster I can save this data on the disk, or faster I can save this data on the network card, and vice versa. So that's the reason one of the, let's say, the facets you should be looking at while learning any computer languages, what data type it supports, and secondly, what is the memory footprint of that? Because the serialization and deserialization will be much more faster. Great. So if you have understood this concept, what we'll do is we'll quickly go through a simple code and you will be able to appreciate the beauty of serialization. So this is a Java code. Again, you can map it to Python code also. There are two instance variable here, like which is of significance to us. One is integer and the other is string. Just keep in mind this integer 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. If it's an integer, it will allocate only 4 bytes in Java. But the moment I change this type here to string, then it will start allocating 8 bytes. And when I say allocation, in the RAM I'm talking about, right? So let's quickly look at it. There are two functions. This first function goes ahead and tries to write this data onto a file. So what we are doing is we are opening a file name. What we are doing is the first integer, we are giving it 4 bytes, wrapping it inside the 4 byte and writing it onto the file. Just consecutive to that, we are writing the name. So if I run this code and save this data, how many bytes I should see on my file? 8 plus 4, which is 12 bytes should be exactly saved. So let's first of all go and execute this. Okay. So now you can see here, this was the file name, integer string.dat. And then you see here how many bytes it has stored, which is 12 bytes. What if we change this to string? And now instead of storing that as a byte, I am trying to store that, sorry, I can still have this as an integer. What I'm doing is I'm just converting this integer into a string here now. And I save it again. So now what should happen? How many bytes should get stored? 8 plus 8 should be getting stored here. Because integer only allocates 4 bytes. Because as you saw in the previous diagram, that when you convert a number to an integer, the conversion happens this way. But once you try to do the mapping of any string or a character, then the mapping happens based on the ASCII character code. So if I execute this code once again, you can see here, just look at the number of bytes saved. It has become 16. Now some interesting part that, hey, this was a number, this was a string, but while saving the data, I wrote the data as a string here. So both my roll number and name are being saved as a string. Interestingly, and here is the most interesting part, I can read the data back from my file system. So this is known as deserialization. And here is the part, folks, I want you to focus because this is the most interesting part, that your hard disk has no understanding of the data type because the data type is pretty much like the schema. Just like in your database, you have a schema, you are saving some data. But while you retrieve the data, that data will be mapped to a string or a char or whatever that is. It's based on the schema that you have defined. So it means that if I read the data from my hard disk, it's a pure byte array. I should be in a position to figure out, hey, take the 4 bytes or 6 bytes or 8 bytes and interpret that as I want. So as I mentioned, you can see here, written everything as a string. But see, while reading, I am reading the data as an integer. Because what this read in does is, it reads the first 4 bytes from your byte array. So it means that if I run this program, whatever I have written and whatever is being read, they will look differently. Can we just verify that quickly? Now you can see here, I had written 1, 2, 3, 4, 5, 7. But now if you go and try to see what I was able to read back, you see this number is completely different. And the reason being, when you were saving it, you took 1, 2, 3, 4, 5, 6, 7, 8. You mapped that to as a string. The string went to this mapping, whatever one was represented as 49. That 49 got converted into bytes and got saved. Now when I am reading it back, here, I am reading the 4 bytes together. I just get an array of whatever 0, 1, 0, 0, 0. I apply this logic and then I am able to form back my digit. And this is the digit which is being represented here. So just a quick call out that again, when you serialize, you are able to convert an object into bytes. That byte can be saved onto a disk. That byte can be sent over a network. That byte can be mapped between your code and the RAM. When you deserialize, the schema or what is the interpretation of the byte remains with the programmer. The hard disk has no understanding around that. Or the network card wherein the data is coming in as byte array, uh, it's only the browser who knows how to interpret this data. So the schema and the data, they are not associated. They are loosely coupled. And the same idea is mapped to your databases. If you look at your Spark, your MapReduce, your data warehouse, Redshift, Snowflake, the same serialization and deserialization keeps on happening. And that's why the schema becomes so central. Because when you're reading the data, how to what how to package those bytes depends upon you. When you are writing the data, how to convert the data type into the actual byte mapping depends upon you. So this whole concept, because this was being used multiple times across multiple different projects and customers, a common serialization frameworks were created, and few of the most famous and optimized serialization frameworks were Apache Avro, Protobuf, uh, and the Thrift. There are many more, but these are quite famous at the moment. So again, if you start mapping it to, you will realize that, hey, my database supports only Avro data. In IoT, the data is transferred from the vehicles or from the IoT things onto the cloud using a protobuf. So what is that exactly? Because from the vehicle, if you want to push data, you somehow have to convert that to bytes. So what is the most optimized way of conversion? People will start using protobuf for that. While reading and writing files, you have your Avro, your protobuf, or your thrift data that is being used. So that's the reason when you look for big data solutions, you will realize that people say that, hey, I want to write my data in a column format or a row format, and this is the serialization mechanism I'm having. In Spark, another serialization is there, which is known as Kiro. So I hope now you're able to correlate that the serialization and deserialization starts from the time your program gets loaded into the memory and you start mapping it to your RAM. So based on the data type, the serialization, this is the first place the serialization happens. Again, RAM sees only 1010, while in the code you see integer, character, string, blah, blah, blah. Because the schema is in the code, the actual byte array mapping is on the RAM. So I hope you are able to get a crystal clear mental model around this topic. Uh, Hope to see you for the next session, which will be about contracts. Thank you so much.